It's been a while since my last update, and there might be some big changes coming up, so let's quickly run through what I've gotten done. The plan was to work on replicating how the bolt locks and unlocks, which you may remember is this motion right here. The first thing I did was create a new component called a motion filter, so I could implement ramps. The point of these filters are to help us decide which motion solver to use when a part has multiple movement modes. Specifically, I apply ramps to these angled edges so that when a bolt gets a hit here, we'll switch from using the slide solver to the lever solver. Otherwise, we would send a hit pushing the bolt in the y-axis to a slide that could only move in the x-axis, and then the motion manager would think we're stuck. Once that was done, I needed to go back to getting levers to work in more than just the default orientation. This was fine for the trigger and the hammer, but the bolt needs to rotate around its x-axis, not its y-axis. Now, the ultimate question, does the bolt actually work? Let's find out after the obligatory ad roll. Thanks again to JetBrains for providing me free access to their toolkit to help with Unreal Engine development. Give them a look and use the following promo code at checkout for a 25% discount on a personal annual license. Yay, we did it. What do you mean that's it? Well, sure, maybe it looks and sounds like it was simple, but as always, let's break down all the fun problems I ran into while working on this. I don't even know how long I spent fighting with the engine to give me decent rotation results until I finally just said, screw it, I'm tearing up all this code and figuring out how to get rid of as many special edge cases as I can. Eventually, I ended up reworking the entire custom rotational sweep algorithm. Thankfully, it actually works a lot better now and requires way less fudging. Now what I do is incrementally check for overlaps every 5% of the requested rotation. Then, if I ever do find an overlap, I do 4 tiny sweeps in the plane that the part rotated in. So if the part rotated around the y-axis, then the sweeps need to be in the xz plane. This plane is calculated relative to whatever axis the part happened to rotate around, so it should work for any case. The reason for this is that an overlap test doesn't tell me what direction I hit the object from. It just says yes or no, while the sweep gives me a proper hit result. Now, there are still some special cases I have to be careful of, but these are all based around what I call depenetration. So in the case where we're at the beginning of a motion due to being hit by another part, it's possible that we see an overlap with that part because it's extremely close to us. So we can just ignore this case most of the time. What makes this more complicated is if the thing that pushed us also happens to be on the other side of us. So we have to be extremely careful and check that the normal of the early hit with that part is in the same direction that part pushed us. Yeah, it's still kind of fudgy, but what's that saying? You can't make an omelet without a little fudge or something. I hope that wasn't too technical because this isn't even my final form. Just stick with me and we'll get to the big decisions in a bit, okay? Okay, so while I was redoing the rotation sweep algorithm, a lot of the same things applied to the linear sweep algorithm, but I was able to catch myself being very dumb. A lot of the parts have children underneath them, meaning they will all move whenever the parent moves. So I need to also consider those parts during the sweep. For example, the firing pin is a child of the bolt carrier, so if I ever move the bolt carrier, then the firing pin has to follow. The original sweep function only took a start and end location in the world, and then I called that function for each piece of collision on the parent and children. That means I was actually sweeping the children as if they were at the parent's position in the world. What I really need is for them to be swept from the start to the end location, plus their offset from the parent first. This fixed a bug I found where at different rotations of the player and weapon, the parts would get completely stuck for seemingly no reason. Now I make sure I'm sweeping from the world transform of each child, not just the parent's location. Even better, this means I might be able to scale down all my models again. If you remember, I scaled everything 10x larger to avoid some seemingly nonsensical collisions, which you can hear more about in my last video. Unfortunately, that means I also have to remember to scale sim values up or down correctly depending on where they're being used. I haven't checked yet since I'm in the middle of so many other changes, but this could explain that problem too. The child parts essentially got moved to a different location for the test, but I would only ever see them where they actually were. So yeah, that'll be exciting if I can forget having to screw around with the scale of values in different places. There were a few other hyper-technical fixes I had to make, but they're not too interesting. I fixed some collision tunneling and sometimes rotating the bolt wouldn't push the carrier backwards. Alright, so that was my 3D math hell for the past 3 months. And obviously now the code is perfect and has 0 bugs, right? Well, surprising absolutely no one, no. We've got some major engine level obstacles ahead, which means big decisions to make about the future of the project. Which, it's pretty much par for the course when you're trying to use an engine for something it wasn't built to do. So I'm not complaining. Don't let running into hard issues get you down. Look on the bright side. It's going to feel great when you finally break through something and realize by struggling, you actually understand way more now. There's still some small issues I need to not forget though. Most likely just some quaternion nonsense. Sometimes the bolt does rotate wildly out of its bounds, and certain actor orientations cause micro overlaps that aren't getting cleared by my depenetration checks. Oh, and I need to optimize the case when parts are hooked together like this. It causes way too many tiny collisions, which leads to a lag spike. And now, finally, on to the real meat of the video. As it turns out, the collision simulation is totally inconsistent across build models. Yeah. It's interesting that in each build mode, the behavior is essentially deterministic though. But even doing something like enabling a different amount of logs can change how the simulation behaves. I think you can imagine how maddening it is to fix a bunch of bugs and then turn off the logs or test the release mode and have everything be totally different. Especially because the motion algorithm itself should be deterministic as long as the input and collision results are exactly the same. So I had to go digging for vulnerabilities, and I was able to fix a couple quickly, but one thing I can't really do much about is the inherent differences between debug and release builds. Now, I don't want to melt any brains any more than I already have, but we can imagine the problem like this. Let's say I do these operations. C equals A times B. Then C equals C plus D. In debug mode, they will happen separately, and I would be able to check the value of C before D gets added to it. However, in release mode, the compiler can choose to optimize it as C equals A times B plus D in a single step, which is fine and perfectly the same, except when tiny difference in the values are actually important. Now think about how our parts move. They end up being very close to each other during a hit, and even small differences in that final value of some calculation could, maybe, propagate through the simulation to change the total behavior. So even if the rotation of an actor is only 1/100th of a degree different, then the calculations we're running on the tiny space between parts can easily get switched when we're asking a simple inside or outside question. And that's just one example of an optimization the compiler might do. It's not really feasible to turn off all optimizations or try to do all my debugging in release mode. So we might need to figure out a way to protect the simulation from floating point silliness, but maybe that's not even the issue. We could be dealing with a stale physics scene. I found discussions about how in release builds, the engine is much more aggressive about batching changes to the physics scene and sneaking in work at different timings during the tick. Since I hadn't considered exactly when we're doing the work before, my current implementation just does things immediately as it's asked to do them. This means the algorithm's loop of sweep A, hit B, update A, then sweep B, and so on, might be getting old data for the sweeps depending on where in the tick we happen to be running. And the updates we do might not be visible to future sweeps in the loop. There is a parameter you can pass to force the updates you're doing for that single component, but we can't know if any other component in the scene is stale or not right when we start. And remember, we have no idea when we're going to start, because the motion manager doesn't schedule anything or run during the tick. It only provides the data for anyone who wants to run the solve motion function. So it's not like we can just switch the tick group to post physics with the current design. Is any of the above actually causing the inconsistency between release and debug? Who knows? The only way to answer that question is to tear up the whole design of the system to try to avoid a stale physics scene, and then maybe we find out it doesn't fix anything anyway. Okay, then where does that leave us? Well, some of you might not like this, but I think it's time we reconsider the live simulation aspect of the game. Settle down, hear me out on this. If we're going to do a major refactor just to find out that the issue isn't the stale physics scene, or that there's just going to be an endless struggle to fix the inconsistencies with tiny collisions and floating point accuracy between debug and release, we might just be better off imposing a bunch of limitations on the builder mode and then baking that output for use during missions. Now, what does that mean for the game and players? Likely, we would have to drop the fully interactive features. So even though it's cool that you can directly control every part of the weapon, there are a lot of other features that the game needs. And if we're lucky, I might be able to figure out a way to fake this well enough. But before that, the plan would be to revert to a hotkey-based input system very much like receiver, but customizable by the player and what I call multi-tiered. Multi-tiered means you can assign multiple actions to a single button, so hitting R does all the smaller steps you need. I always planned on having this as a backup mode anyway for less hardcore players, so we're not really gaining work here. Also, having the collision sim only in build mode means the game should be more accessible to people with lower end systems. A low-end machine won't have to run mission logic at the same time as the simulation. Another way to look at it is that maybe this would give us a bigger budget for more complex missions and AI as well. And I'm not promising anything, but maybe this gives us room to put multiplayer back on the table. On the other hand, we would definitely lose more emergent mechanics like weapon jams or misfires based on things like heavy weapon usage, environmental conditions, or whatever. Which is to say, it would require extra effort to specifically add those things in as scripted events instead of being emergent mechanics of the simulation. I'm not saying we have to take them out of the game completely, just that every type of failure would have to be a bespoke feature I implement. You can think about how Far Cry 2 arbitrarily decides that your weapon is dirty now, so it jams some percentage of shots. And then if you keep going, it puts you in the worn out phase and your gun explodes. On the positive side, it should be much easier to have a deterministic build mode. Instead of trying to complete whatever random work we're asked to do in a single frame, we can control the exact time steps of the sim part by part for every millisecond if we want to. Considering one frame at 60 FPS is over 16 milliseconds, we probably don't need that kind of resolution. My point is that design constraints are much more strict for a live sim. A downside of this is we would have to have a lot of explicit states for different types of missions to be meaningful. So if a mission has you go from an icy tundra to the Sahara, there can't be a smooth transition because a build mode can only simulate a finite number of states like frozen, cold, hot, melting, or whatever. To be fair though, that is probably easier for players to understand and plan around. Do we want to give the player a mission and then they find out mid-firefight that their gun doesn't work at exactly 48 degrees? I know somebody out there is screaming yes at their screen right now, but maybe that's something that should wait for a sequel to a successful game. So yeah, a lot to think about right now. Oh, and by the way, this doesn't mean scrapping everything and starting over, but maybe that's what I should title a video to be a good YouTuber, right? I'll think about it. If I did do that, sorry about it, I guess. I mean, sure, if I do abandon the live sim, there will be some code that becomes irrelevant. But what I mean is, I need to do a major refactor to test the stale physics scene hypothesis anyway. So it might make the most sense that while I'm doing that, I might be able to make up a lot of time across the whole project by only targeting an offline sim. Maybe this is the best time to cut the cord and accelerate development down a stricter path. Basically, stop fighting the engine just to do something cool, and focus the target on only getting specific states functional. Anyway, here's my next steps. Whichever way the sim goes, I've got to start paying off my technical debt. For those who don't know, technical debt is what we call it when we keep pushing through the development of something, maybe ignoring small bugs or maintenance items, to stay focused on a larger issue. If you keep ignoring the small things, you'll end up in death by 1,000 cuts territory eventually, and I think we're where the backlog of little things is threatening to get a little too big. And it will be nice to get some small wins to recharge my batteries anyway. I mentioned I modified the sweeping algorithms. That was easy for linear sweeps, but I still need to fix rotational sweeps, which are a bit more convoluted, and I don't actually have any children under rotating parts yet anyway. So I had put that on hold to focus on the bolt unlocking. I also need to clean up how the filter solvers get looked up and applied during sweeping. And I want to learn more about the Chaos Visual Debugger. That might help me learn some things about stale physics scenes before I go into a big refactor, but I don't have too high hopes. Updating to Unreal Engine 5.6 is probably a good idea since I'm still on 5.4, and it's important not to get too far behind. I might also want to start building the engine from source, especially so I can enable logging for release builds. Then when all that's done, I'm going to take my dreamer hat off, put my project manager hat on for a minute, and decide what the fate of the live sim should really be. Let me know if you have a strong opinion either way, and as always, thanks to all my supporters, and thank you for watching.